Welcome. It's the Electricity and Magnetism Laboratory, Physics 225. My name is Dan Ludwigson, and I'm here to introduce you to the Coulomb balance. This apparatus will be used next week for measuring the tiny forces between two charged spheres. But this week, before we get to that point, we're going to look at how we can measure these small forces to begin with. So we'll dive deep into the calibration of this torsion balance. Let's shift to the point of view of the operator as we're using this torsion balance, this Coulomb balance from Pasco. You see on top is the dial, which shows the angle of twist, and that dial is connected to the torsion wire, that thin wire that extends down through the pendulum apparatus all the way down to where it's secured at the base. And it's just resting underneath that strip of aluminum. All right, when we unpack this, it might be secured here for storage. We just undo this, and then we can loosen that up, and then rotate that out of the way. Now I want to set this up so that that index marker is nice and perpendicular. And then at 0 degrees, I should see those two lines line up. Now, they're not in this case, so I need to gently go underneath. Do not unscrew that thumb screw, but just rotate that plastic stopper. Just rotate that in the direction that you need the wire to twist until those lines line up. Oh, I went too far. Come back. And you get those to line up. Our next step is to establish the sensitivity. That is really the heart of calibrating this instrument. What we want to find is the number of degrees of twist that corresponds to what particular force is applied to the sphere at the end of this pendulum. So we need to apply a known force. In order to do that, we take some of these very tiny masses. This is 50 milligrams. There's a couple of 20 milligram masses. Now I don't touch these because I don't want to transfer any dirt or oil to those tiny masses. We'll move this kickstand out and then turn this guy on its side so that we can apply these forces vertically using the force of gravity with the masses. Now, you notice that the pendulum balance stayed in balance because the torque from the mass of the sphere is balanced by these counterweights on the close side. If it doesn't stay horizontal, that's okay. Just call your instructor over. You can gently adjust those copper rings to move the mass distribution so that this becomes balanced. What we'll do is we will support the sphere, add a tiny little bit of mass, and then obviously it's going to sink. It's now no longer balanced. But if I apply a twist, I can get this to come back to equilibrium with a certain number of degrees of twist. So that's pretty close. It's back to equilibrium. Now, I just read off the number of degrees for that amount of mass, or that amount of gravitational force that I've added, and I've got one data point. I collect several of these data points, plot them on a graph, and that gives me the amount of force for a given degree of twist, or vice versa, how many degrees of twist for a given amount of force. Finally, I'd like to add a couple of words of warning, a couple of cautions as we work with the Coulomb balance. Number one, you don't want to rest your hand on top of this as you're moving the dial. don't push down, because that will loosen up the torsion wire, it'll loosen the tension in the wire, and cause the pendulum to sag, all kinds of other problems. Number two, the dial and the ring might be a little bit sticky. So if your center ring is turning without turning the entire dial, you might be stuck on a sticky point. You can move that outer ring so that you move through the stickiness. Then finally, most important, be careful in this area here. I've seen so many students inadvertently break the wire just by nudging it, bumping it with their hands. They're trying to reach through or reach around into this area. It's really easy to knock that out of place. So just be careful in this area. Be careful with the Coulomb balance in general, and you'll have great luck with this very delicate, precise instrument. It rewards the careful experimenter's efforts.